So properties of real numbers. We kind of did this a little bit yesterday with our review on what we can move to the left and to the right, and division and subtraction, and how to get stuff by itself. So here are the properties, and you already know how to do these things, and you know what they are. You've been using them since grade school. We're just putting these names to them. You especially had this in Algebra 1. So the commutative law for addition says that I can add numbers in any order. Okay? So if I add 3 plus 4, that's the same thing as adding 4 plus 3, isn't it? Okay? So we're just saying that with letters. That you can just flip that order around and you're still going to get the same answer, which that's really good for us, because if 4 plus 3 was not equal to 3 plus 4, math would be so much worse. It would be awful. It would be a nightmare. Alright, so properties of real numbers, you've got your commutative property of addition, you've also got your commutative property of multiplication. You can multiply things in any order, and it's going to give you the same number. Is that 3 times 4 is the same thing as 4 times 3. That's what we want. We want 12 to equal 12. So remember the commutative law. Commutative has the root word commute in it, and commuting means you just move around, right? You're going from point A to point B. That's how I remember. I can flip them around and do whatever. Because the distance from the high school to your house is the same distance as your house to the high school, right? Your commute is the same no matter what direction you're going in. Even if it is snowing and you're going uphill both ways, okay? It's the same either way. So the associative property of addition, that's when we start throwing parentheses in there. It's just saying I can add A and B together first, and then I can add C to it. And that's going to be the same thing if I added B plus C together first, and then added A. So you can do it in any order that you like, as long as you follow the order of operations. Same thing with multiplication. You can multiply A and B together, and then multiply it by C. Or you can multiply B and C together, and then multiply it by A, and it's the same thing. So the identity property, this is pretty important. You all use this a lot, and it looks different whenever you all use it, so it's kind of like, what's the point? So the identity property for addition is that I can add 0 to anything, and I can get the same thing back. And that is the thing whenever, and you don't have to write this particular part down, this is whenever we've got negative 3x plus 4 equals 5. That's why I can add negative 4 to both sides and get this negative 4, or get this 4 over here, okay? That's your identity property working, because it's saying I'm the same thing, okay? I've added 4, negative 3x plus 4 minus 4, that's negative 3x plus 0. That's your identity property. Same thing with multiplication, except your identity is 1. So any number times A, or any number times 1 is that number. Okay? And you won't always see it like this. Right now this seems like a pretty pointless and stupid rule, but if you're trying to manipulate things and get rid of stuff, knowing that you can multiply A times B over B, that's 1, A times 1. Still the same thing, it's a different form. You don't have to write this part down. This is a little bit of a little example of what's going on. So your inverse, right? This is also your inverse property at work down here. Your inverse property for addition is A plus negative A is equal to 0. Okay? And this is actually why we don't have rules for subtraction. Like, we've got rules for addition and multiplication. Well, how come we don't have them for subtraction and division? Well, this inverse property takes care of that for you. Okay? A plus its opposite is 0. See what I did here? A plus its opposite. Yes, sir? Wait till I get through. This won't be much longer. A plus negative A is equal to 0. 4 plus negative 4 is 0, so that's your inverse property there as well. Inverse property for multiplication. This is when everybody gets scared whenever they see a fraction. A times 1 over A is equal to 1. Like yesterday, we had one of those problems. We had x over 5 was equal to, I don't know, 2. We used this inverse property to get rid of this on the bottom, right? So 1 over 5's inverse was 5. Okay, so if I multiply both sides by that, I've still got the same thing. Those cancel now because 5 times 1/5 is 1, and then 2 times 5 is 10. Okay, this keeps it even. That equality sign is what you're always going to look for, and that's what we're doing in algebra. When are things equal to each other? If you do one thing, what's good for the goose is good for the gander, is your philosophy for doing math, okay? If you want to do something over here, you better do the exact same thing on the other side of the equal sign. So your distributive property now. A times B plus C is equal to this. You distribute it so everybody gets multiplied. Everybody in the parentheses gets multiplied by A. So A times B plus A times C. Say again? Exactly. And what we're going to do a lot, too, later on, you're all used to the distributive property going from here to here, right? When we start factoring stuff, you're going to have this and have to go back to this. So you've got to learn common factors, how to find your factors of stuff, what's common between numbers, and then go, whoop, I'm going to pull that out of there because I want to simplify my problem and get rid of stuff. So we'll look at these and we'll notice a few properties here. So I've got 5 times 2 times 8 is equal to 5 times 2 times 8. Okay? What's the difference from the left side and the right side? The parentheses are switched. Okay? So which one of these rules have I got that says you can switch the parentheses when you multiply? Associative. Good. Alright, so that took a really long time to write out. So I'm just going to abbreviate later. Alright, so 14. 6 times 3 minus 7 is equal to 6 times 3 minus 6 times 7. What's the difference between the left side and the right side? Took everything out of the parentheses and multiplied it. Which one of my fancy rules says I can do that? Distributive property. Alright, so 7y plus negative 7y is equal to 0. What's happened? Say again? Inverse. Which inverse? Addition or multiplication? Addition. So inverse addition. So 3a plus 2b is equal to 2b plus 3a. And this is how I do my math problems. What's the difference between one side and the other? And can I identify, after I figure out what the difference is, can I find one of these fancy properties that says, hey, you can do this? So what's the difference between 3a plus 2b equals 2b plus 3a? You started at the high school, or you started at home and you went to the high school. Now you're going from the high school to your house. Which one of those things says that the distance is the same? What? Any of them. All right. Y'all feel like you got a pretty good grasp of that, what's going on with that? Okay. I'm going to let you all work on those 4. I'm going to do a couple of these over here real quick, though. I want to do 2 of these. So you see what's going on. Name the additive and multiplicative inverse for each number. Right? So I've got negative 8. If I want the additive inverse of negative 8, what's its opposite? 8. Okay? Now I want the multiplicative inverse. Okay? How do I get a 1 from a negative 8? I can multiply negative 8 by something and get a 1 back. I heard negative. Right? So remember, multiplicative. You want to multiply it by its fraction. So negative 1/8 is its multiplicative inverse. Alright, so number 22. What's the additive inverse of 2/3? Negative 2/3, because that gives me a 0. So what do I multiply 2/3 by to get a 1? 3/2. Alright, so we're in math class and we like to prove things, so let's do it. 2/3 over 3/2. Whenever we multiply fractions, you just go straight across, right? So the top times the top, bottom times the bottom. 2 times 3 is 6. 3 times 2 is 6. 6 over 6 is equal to 1. Good. Okay? What I wanted. Closure. That's a pretty good question. So a set is closed under an operation, see, if the operation always produces an element of the same set. So if you start in the integers, after you add or subtract or multiply with it, it gives you an integer back. If you start with a natural number and you do some operation to it, the answer is a natural number. That's what it means whenever it's closed. Okay. So integers are closed under multiplication. Off the top of your head, do you think that's true? If I multiply 2 integers together, and that's why you need to know what these sets look like and have a pretty good understanding of them. You need to be thinking, what's an integer and what happens when I multiply by integers? So somebody give me an example of 2 integers. What? 3 and 2? Alright, so 3 and 2 are definitely integers. So if I add them together, 3 plus 2 is what? 5. Is that an integer? Yeah, so it's closed under addition. What about 2 times 3? What's 2 times 3? 6. Is 6 an integer? Yes, so it's closed under multiplication. So that is true, because it gave me a number back in the same set. Alright, so irrational numbers are closed under subtraction. So you got to think, oh no, what am I doing here? What's an irrational number? Right? So think of an irrational number. You've got 2 that you should have off the top of your head. Always whenever you hear irrational number, either think of pi or think of square root of 2. Those are your basic examples for an irrational number. So what are we doing? Closed under subtraction. So pi minus pi is equal to 0. So what is 0? It is a whole number, correct? It's not irrational, so it didn't spit back an irrational number, so it's false. Alright, so whole numbers are closed under addition. So whole numbers. What numbers can I work with? Which numbers can I start with? You can refer back to your notes. That's why we got them for. If you don't remember, that's perfectly fine. So whole numbers start at what number?
0.
0. All right, so pick two whole numbers. Let's do 2 and 3 again. All right, so it is 2 divided by 3, a whole number. It's 0.666 repeating. It's a rational number. So it didn't give me a whole number back, so it's not closed. All right. So odd numbers are closed under addition. Now we need 2 examples of an odd number. What's the first couple of odd numbers you can think of?
3 and 5.
3 and 5. All right, I like it. So 3 is odd, 5 is definitely odd, but 3 plus 5 is 8. All right, so is 8 an odd number? No. So it is not closed under addition. It is false. Anybody got any questions over anything? Feel pretty good about it? Right. So this is what I want you to do in the meantime. 17, 18, 19, and 20, and then 23 and 24. Do those 6 problems for me. And we should